Thank you for the invitation. My name is Roman, and I'm a technical director in the Polish division of Dimplex company. Basically, we are the German company, but we have the strong Polish division, and I'm responsible for the technical matter and technical support and technical issue, all kind, and also for the after-sales service. So that's the task what I'm involved. Today, we would like to present you some ideas about the modern heat recovery using the heat pumps, especially dedicated for the retails, magazines, retail stores, food stores, where there are a lot of heat loads, internal heat loads, and a lot of cooling capacity necessary to keep fresh the products. So there is a lot of energy to use, to spend, and for many years this energy was losing, but now we are looking for the solution how to collect this energy, how to spread it in the right way. And that is the main topic for today. I will do some short introduction about the heat pump in general as well, but later on I will show you some examples how we arrange, how we set up the systems for the heat recovery and heat transfer just to be safe. As I said, today we will talk about the heat recovery system, especially from the markets, from the stores with the food. And at the beginning, I would like to present you some information about the company. We are the manufacturer of heat pumps under the brand Dimplex, and the manufacturer is located in Germany, Kulmbach in Bavaria. However, we also deal with the cooling machines under the brand Riedel. Riedel is the dedicated brand to producing the precisely cooling devices. Some facts about the company. In Germany, we started heat pump business in 1970s. It was the beginning of this story, of this technique. The first machines were created and established, and after years, all the technique was developed step by step, up to date, when we have really high efficiency products. In general, we are under the global Glen Dimplex group, and we provide electrical equipment for heating as well. It means radiators, heater, air curtains, and stuff like that. We are visible on the 26 countries in 4 continents. As I mentioned before, we are also producing under the brand Riedel cooling systems such high capacity, high range output power cooling machines, especially dedicated for the industrial companies, for the industrial purposes, for the medical installation, for the production, very precise with very detailed controlling systems. So the controlling of the temperature is really outstanding. At the beginning, I need to say that we are responsible for the climate at the moment. You know the situation about the global warming and CO2 emission. But the situation is at the moment that 35% of energy consumption from the countries, these figures are related to the Germany basically, but in Poland also the situation is the same. It's pretty similar, the same. The energy dedicated for the heating of the buildings takes 35% of the whole energy consumption by the country. So this huge amount of energy, as the result, gives 40% of emission of CO2. So today we are really focused to reduce the emission of CO2, and our European Union standards are growing, and we are obligated to fulfill some guidelines according to this. What is these guidelines. The plan is to achieve in 2050 climate neutral as the whole Europe, and we need to increase the reduction of CO2. At the moment, the agreement is 40%, the reduction of CO2 emission, but the new proposal from European Union is upgrade this figure to 55%. Another step is to use more renewable energy sources. It means that today we have 32% obligation of the RES share in the total energy production, but in future it will be 40. The proposal is to increase this figure, this amount, this share, up to 40%. And the third step is to improve the energy consumption of the buildings, and that is also related to the topics for today, and increase the efficiency of the buildings. It means better insulation, better heat recovering system, lower emission, and lower final energy consumption. The new proposal from the Union government and authorities is achieve 31% of reduction final energy consumption for the buildings. In Poland this year, our government, our authorities implemented new regulations about this, and today we have really strong energy consumption demand for the new buildings. Especially, this is good information for us because these new figures, which must be fulfilled, are really dedicated for the heat pumps. So only heat pumps can achieve this strong demand of the final energy consumption. Comparing to gas boilers, for example, it is pretty hard to achieve the maximum available level of the energy consumption for the new buildings from this year. Let's see what is the CO2 emission in total from the energy mix during the electricity production in different countries along the Europe. You can see the average figure for the Europe is 226 gram CO2 per kilowatt hour. But unfortunately, Poland and Estonia are the leader with this bad issue, and we produce more than 700. Estonia produce more than 600 grams CO2 per 1 kilowatt hours. So it is really high level, and we need to do something to avoid this problem, to reduce this emission. That's the point which gives us possibility to use heat pumps, and why I will show you on this slide. This blue line is the CO2 emission from the electricity production at all, together with RES sources. If we will increase the RES share of this production, the figure will drop down. So photovoltaic or offshore energy production get better these factors. However, emission from gas burning from gas boilers is on this level 221. But if we consider the heat pump with high efficiency factor, for example, SCOP, seasonal efficiency factor 3 or 4, this amount of emission is lower than gas boilers. So this is the general direction, especially for the heat pumps, and the heat pump technology is recommended basically by the European standards and European regulations. This is the great benefit for us to grow up, to increase the production, to increase the technical issue, and to develop more and more better products. The goal is to achieve from the production of the energy the level 100, and this level is dedicated to achieve by the Union, and this level, the technology to achieve this level are supported by the financial loans or subsidies or stuff like that. That's the future. We are expecting in 10 years achieving this reduction from the start point almost 40% less of the total CO2 emission during the electricity production. Okay, let's say something about the heat pumps. This is a specific device which not produce the energy, but it transfer the energy. We need some source of energy, low source. It is called low source, low temperature source, and we need the power, we need the energy for running the system, the device, and after that, as the result, we get the amount of energy supplied to the building for heating purpose or for domestic hot water or for any other purposes, for example, for manufacturing, for warming up some process, etc. The heat transfer is going through the circuit, closed circuit. We have 4 main stands in the device. The first one is evaporating, then compressing, and then condensing, and pressure expansion. Inside the circuit, we have the refrigerant, the gas, which is important that the refrigerant can evaporate in the low temperature. So that's the great benefit of the refrigerants, to evaporate with the low temperature. So even if we have low temperature downheat sewers, we can achieve quite nice temperature on the other side after whole process. How it looks with figures. The evaporating from the downheat sewers is running even above 0 temperature high with low pressure of the refrigerant. After compressing, we get more than sometimes 16, 17 bars in terms of in case of ground heat sewers, but in case of air-to-water heat pumps, the pressure is higher, even higher. And after compressing, we also get the higher temperature. All this process is good shown on the diagram relating pressure of the refrigerant to the enthalpy, so the amount of energy. This evaporating is this flat line from 4 to 1 point. This is the evaporating, so this is the extracting the energy from the downheat sewers. Then compressing is from 1 to 2. We have higher temperature at the outlet and higher pressure on the other side after compressor. Then the evaporated gas going through the condenser and condense and spread out the energy to the liquid, to the medium from the installation. The condensing is adiabatical, so there is no heat losses. The pressure, the pressure, I'm talking about the pressure reduction, but the condensing, of course, is the heat transfer, so we spread the energy from the higher enthalpy point to the lower enthalpy point. And then the final process, closing all this circuit, is the expansion, the pressure expansion via the expansion valve. And then we have adiabatical change from 3 to 4. It is without any losses. We only reduce the pressure of the refrigerant. So this circuit is closing all the time running the same way. And the process is described. This process is described by the COP factor. What is this? This is coefficients of performance, and this factor gives our information what is the efficiency, how many profit from this process comparing to the input. So, for example, if we get 73.6 kilowatt output power, we need to use 15 kilowatt energy and electrical energy for running the compressor. It gives 4.8 COP factor. Important fact is that COP is calculated in the single separated conditions with the concrete temperature down heat source and concrete temperature of the heat of the upper heat source. There is a different factor for describing this process, the seasonal factor, also SCOP, but it is related to the whole year production of the energy. So with average figures, with average temperatures, and different temperatures changing all the time from the both sides. What is important to remember regarding to this process, that our COP factor is strongly related with the down heat source temperature, and if the temperature, down heat source temperature is lower, the factor goes down, decrease, and the cost of operating is growing up. So in my mind, we need to follow the rule that the better system is the system with the higher temperature from the down heat source side. Pretty the same story is with the high heat source side. If we have lower temperature, running temperature, supplying temperature of the installation, we have high COP factor. So our goal is to keep as low temperature on the outlet from the heat pump to provide the efficiency heating, for example, with the floor heating or wall-mounted heating, etc. And the lower temperature on this side, the higher savings, so low cost operating. If we connect this installation, this device, to the high temperature systems, for example, radiators on fan coils, etc., we can spend much more money for operating cost. Let's say something about the products, especially dedicated. It is not whole range of portfolio. These products I will show in the next slides are rather dedicated to the heat recovering systems, and later on I will show you some diagrams with these products, and everything will be clear. What we have at the moment for this purpose, for the heat recovering system, not typical. We have a range of air-to-water heat pumps, especially larger machines from LA 25 to 60. It is the capacity of the device. It is dedicated. These two machines, these two ranges are dedicated for bigger houses or for such plants, for such installation as you are interested for the heating recovery in retail stores. Also, we have some smaller devices in the range, but they are rather dedicated to the single-family houses. I need to say that our existing range of product is based on, mostly it's based on R407C refrigerant, but we have some products with the R290. This is the propane. We have two machines at the moment, the approximately 35 kilowatts and 60 kilowatts. But the situation will change because Also, there are new regulations about the refrigerant for the heat pumps. This is also related with the emission of CO2 and global warming problem. So now we are in progress to look for the new refrigerants for the heat pumps. And the best solution for the outdoor unit, outstanding unit, is propane, because it has quite good operating limits and good flow temperature, supply temperature, even at air -7, the temperature of the surrounding air with the heat pump is working. So the proposal is to build more heat pumps with R290, the propane gas. But of course there are some problems, some technical issue about the explosion danger and stuff like that. We are looking for the best protections, and it is already solved. We have 2 machines, as I mentioned. But there are also some difficulties. We need to fulfill the safety concept for mounting these devices and keep the standards. For indoor machines, the propane is not okay. At the moment, our regulations don't allow us to build in the heat pumps with propane inside. So the alternative refrigerant is R454C. It is also okay because it is safety. It is acceptable range of operating, and it is very nice because of the footprint of the device. So the space and the large of the size of the device is as small as possible, just for saving the place in the plants in the room where the machine is installed. This is the simple example how is the system set up with the typical functionality, the heating for the house and for production of domestic hot water. We have the outstanding outdoor monoblock heat pump here as the heat source, and controller, of course, inside the building, some buffer tank, some circuits, internal installations, and some domestic hot water cylinders. The specific way we are using the buffers is that we are not connecting buffers parallel between the heat pump and the rest of the installation, the outlet to the building, but we built this buffer tank in one row. The flow is directly to the buffer from the bottom to the up, and then to the manifolds, to the circulation pumps. But there are some tricky stuff in this diagram. We use a special manifold, 2 bypasses with non-return valves to separate hydronics, for separating the hydronic from the primary circuit with this circulation pump to the secondary circuits with this, in that case, free circulating pump dedicated for the internal installation. So if there are some overpressures, these 2 bypasses can spread it and fix the overpressure. Another product dedicated for heat recovering, especially this range, SI. This is the brine to water heat pumps. These are the brine to water heat pumps from the capacity 26 up to 130, dedicated for larger scale of the plants, of the installations. A typical 2 compressors device stuff without any circulation pump. This circulation pump from the down heat source and to the upper heat source to the installation must be selected individually according to the pressure drops and individual situation in the system. Also pretty the same diagram for operating in the regular condition, but the difference is, of course, here we have a different heat source. In this case, it is the drilling, the boreholes in the ground. But the hydronic inside the building and inside the plant, the setup of the system is pretty the same, and the functionality and the controlling also is the same. In the standard situation, we control the return temperature from the installation, and it is the main measurement point for the controlling all processes with this diagram. Two more brine to water heat pumps, very interesting for heating recovering systems. SIH, this H letter means high temperature. It gives us the possibility to achieve even 70 degrees on the supply side for the installation. So some special cases with necessity of high temperature supplying we can cover using these two machines. Only two capacities, 20 kilowatt-hour output and 90 kilowatt-hour output. Reversible brine to water heat pumps. Reversible, it means for heating and cooling. And the range is 35 up to 130. This machine can operate during the winter time for typical heating purposes, but during the summertime, it can convert via four-way valves on the refrigerant circuit and produce also cooling. In case brine to water heat pumps, the wasting energy can be implemented into the ground with the regeneration of the ground. This is the advantage. And also we have one machine with additional plus. This plus means that this machine is equipped with the second condenser, a second heat exchanger we can use for simultaneously production of heat during the cooling. So we can spread the waste heat directly, for example, to the domestic hot water cylinders or to the swimming pools on some other purposes, directions, for example, some production which needs some special energy, or maybe for ventilation which needs some warming up even during the summer. Water-to-water heat pumps, the larger machines, 35 up to 180 kilowatts output. These are pretty the same comparing to brine-to-water heat pumps. However, they are a little bit more, they have a little bit different controlling system and range of operating. In that kind of heat pump, we have only one at the moment high temperature heat pump, 120 TU WIH. Also the same feature, 70 degrees are available. I need to tell you that today we are finishing a very large project in Poland with these heat pumps. We are building the cascade of 12 devices. It gives the total output on the level 1 megawatts, so 1,500 kilowatts output. It is some district heat supply. This big plant will support several buildings surrounding, and we will warm up the water up to more or less 70. But the downheat source is the geothermal water taken from the earth. We need to remember about the changes of final capacity of these products. Not only brine to water or water to water, but also in terms of air-to-water heat pumps, we observe that the heating capacity is strongly related with the temperature of downheat source. So if the downheat source is higher, the output also is higher, and if the supply temperature is lower, also the output is much better. There are also limits with the temperature in these processes. In case of water-to-water heat pumps, the limit is 5, basically up to 25 from the downheat source for the evaporating the refrigerant. And in case of this high temperature heat pump, the maximum supply temperature is 70. We always need to check what is this field in the documentation. It is important to be in the range. If we have the heat recovering, from the sources with higher temperature than 25 degrees, we need to use a special protection setup. Mostly we use the additional three-way valve with the actuator mixing valve, which stabilize the temperature on the inlet to the heat pump. Of course, if there is some operating liquid different than typical glycol from that side, we use also heat exchangers between the main loop and the heat pump. This small circulation, the small loop is closed, of course, under pressure with the expansion tank and the safety valve. But the maximum temperature for the supply side is 25, and we always need to remember this rule. And let's talk about the main topic for today: the heating recovering system for the stores, for the magazines. This is the principal diagram with the idea. We have the cabinets in the store, which needs to be cooled, and we have the circuit, the loop. Then we collect this energy in the buffer tank, and via the heat pump we transfer the energy. We rise up the temperature and transfer the energy to the secondary buffer on the upper side, and then from this buffer we can spread this energy to the building using the typical installations, for example, fan coils or whatever, or heaters built in the ventilation units. In details, I would like to show you some more developed diagram. In details, this diagram shown on the previous slide looks like this. Here is the loop, the cooling loop for the cabinets. This side is the cabinet side. Then we have, of course, possibility to spread out the energy when we don't use the heat recovering outdoor using the dry cooler. But with these three-way valves, on-off valves, we can direct the flow to the heat exchanger. Then we collect the energy in the buffer with this small short circuit, the circulation pump. Then from this buffer, we have the stabilization of the energy supply for the heat pump using this this buffer, and then we take the glycol, the protected liquid, to the evaporator of the typical brine-to-water heat pump. Then the energy is taken and collected in the secondary buffer, and this is the source of energy for the rest part of the installation, then we have circuits for the installation. The circulation pump, some mixing valve is necessary if we need to reduce the temperature for example, under floor heat system. There are other equipment here. The main device, the air-to-water heat pump. It can support this main device because the idea is to recover as much energy from the cabinets as possible, but sometimes if we don't have enough capacity from this, we can use this one as a backup or additional heat source. We also have possibility to rise up the temperatures with electrical heaters built into the buffer on the upper side. However, also this machine is available to produce the cooling during the summer. It is reversible machine based on propane 290 refrigerant, and it is reversible with the special four-way valve, which also reverses the water loop on the condenser. So during the summer also we can produce the cooling medium with low temperature for supply. During the winter, we are extracting the energy for heating from the cabinets. And the important message is that it doesn't matter what the circuit we have. It can be liquid circuit, water loop. It can be also CO2 system on the down heat source. The functionality and the idea of this is pretty the same. The important also message is that controlling system of this is also provided by us, and it is a quite different controlling system comparing to the traditional, because we are keeping the temperatures on this side. So we are taking care about correct temperatures in this loop. This is the main task to fulfill. The rest is the result. However, we can warm up if we need warm up a little bit the circulation medium, the circulation water in this backup heater. So we provide the controlling system with the electronic cabinet. We also can provide the hydronic parts of this system. In these blue lines, you see what can be produced by us after, of course, some designing process. It is designed individually. We collect all the necessary equipment and build in the workshop a ready, complete, pre-manufactured setup with this hydronic equipment, the pumps, the fittings, the isolators, the piping, the connection, the flanges, and etc. Later on, I will show you some slides about this. So that's the offer, the whole range of the system, basically. The main devices, the hydronic parts of the installation, just plug in. Easy for mounting, easy for better for fast mounting, and easier for installers, of course. So that's the great benefit, and also the controlling system. Three main components of the system: heat pump as the main product, and the rest. Let's see another example of the heat recovering system. We have cooling using the brine-to-water heat pump. This loop is cooled down. We are taking energy from this side. This is our target to keep the low temperature in the cooling system. And we collect the energy to the domestic hot water cylinder or to some other necessities. if we have, of course, the energy consumption, it works perfectly. However, if we don't have the energy consumption, the heating energy consumption, we can turn over to the dry cooler, of course, via heat exchanger, just for protection of the freezing during the winter time, this dry cooler. So this is the glycol circuit, and we have possibility to operate for domestic hot water, recovering heat energy, recovering energy from the cooling system, and if not, spread out the energy to the air. There are some backup connections to the buffer. If the system will grow up, we can extend this system. We can extend this hydronic integration, for example, for the typical cooling device, or add another heat pump as well. Also, with these blue lines, blue boxes, you can observe what we can produce in the manufacturer, in the workshop, and deliver on site, pre-assembled, ready for installing, for quick installing. Okay, the third example in details. We have the cooling cabinet system. This is the CO2 system, the gas. We have the high temperature recovering. So in that case, we directly recover heat using this heat exchanger to the buffer tank. If the temperature available here on this part is higher than or equal the situation on the circuits, we use directly this energy. That is important fact, that if we have high temperature down heat source, we can use it directly. And the common point for the heat pumps as a backup or for the heat recovering is the buffer. So all hydronic is separated, all pressure influences are separated as well. Here we have two reversible monoblock large-scale heat pumps, which can support this circuits during the winter time with the energy. And of course, the reversible heat pumps can produce cooling water during the summer. So multifunctionality system at this hydronic integration. We also offer ready designed and ready mounted parts of the installations and controlling system for this. Of course, important matter is that if we don't need to warm up the building, we have the gas cooler on the circuit from the cabinets. Let's see some examples. What are the results of such systems, heat recovering system? This is the example from key market, Masala, Finland. We have the square, the area, more than 1,100, almost 400 square meters, and that is the layout of the store, of the retail magazine, and that is the measurement of the heating demand, heating consumption for the building without any heat recovering. This is whole year. This is from the January to December. The heating demand in kilowatts are shown on this axle, you can see that only few hours per year we need the high capacity of the system. There is some average figure for that building, which is perhaps calculated according to the designing temperatures on that level, but the realistic heating demand is average like this. And the interesting is also that during the summer we also need a lot of energy for warming up the ventilation air, for example, just after the humidity of the air, using the cooling heat exchanger, we need to warm up a little bit the inlet air for ventilation. So also during the summertime we have quite a big heating energy demand. This is the chart with the possibility of the heat extract from the cabinets. Of course, during the summer, this amount of energy is higher, but it is pretty constant during the less part of the year. And if we use the heat extracting system, the heat recovering system for that building, whatever loop we have on the downside, we will get the result like this. So small amount of additional energy necessary for the warming up the building. So comparing to this figure, it is really perfect result. During the summertime, basically we don't implement any additional energy to the system. And the important fact is that during the summer, in this coldest part of the year, we need to add more or less half heat demand of the building. So the conventional system is not necessary to be measured and designed for the 100%. We can even consider such solution. One more example, another store, a bigger one, but it's really good to go through these charts on the one slide. This is the heat demand for the building. This is the heat recovering, the possibility of heat recovering from the cabinets, and this is the result. So perfect, effective system. Of course, we have some other examples, some other measurements available, but it's only the main message that it could be a very effective system. Coming back to the parts of the system, as I mentioned, we can design and provide you as contractors or executive company with such pre-mounted parts of the system. We can build in the circulation pump. Everything is in the frame, easy for transport, with easy connections, flange connections. Also with the electrical cabinet, with the controller, and with other necessary parts from the electrical side. It looks very compact. There is another example how compact could be the system. Here we have the heat extracting from the cooling chamber, which is located in the greenhouse. This is the example from Poland. In the greenhouse there is the production of vegetables, and we have the cooling cabinet, the cooling chamber for storing the vegetables, and the temperature inside the chamber is controlled by the system of recovering by the heat pumps, we collected the energy in the buffers. Some of this energy we spent for domestic hot water with this cylinder tank, and the rest of energy is used for warming up the greenhouse via the heat pump and via the fan coils. So very compact, very simple solution, all controlled by our steering device controller. And this is the back of this build. Also, all this piping, all these pumps, all these valves and other equipment were pre-built in the workshop and delivered on site, ready assembled, and just for quick installation. Only buffers were more or less separated for transport and for mounting, of course. We can also provide the systems with the solution with the container. If there is no space for building the plant, if we need to save the place for some reason, we can build in all this hydronic integration into the container and locate this container close to the building, or even on the roof. Today, maybe not today, but a couple of weeks ago, in Poland, we were considering with one big retail store mounting such container on the roof because there was no place for the plant, but the roof was okay. Of course, we need to remember about the weight of the equipment, do some consultants about this, but it's possible. This is also the example from real life. This is the photo of this solution. The pretty ready installation. This is the heat recovering from the data center. Yeah. Okay. We need to cool the servers and computers. So this is this issue. At the end, I would like to mention that it's not only the question of heat recovering from the stores, from the cabinets, but also we can recover energy, recover the heat from other sources. We are providing the heat pumps for heat recovering from the wastewater for sewage installations, especially in the big cities with cooperation with the municipal plants for sewage cleaning. We are using this kind of heat exchanger or a little bit different heat exchanger dedicated for this purpose and produced by other companies, of course, special ones, easy for cleaning and quite effective. Steel, stainless steel, always in that case. And another possibility of heating, extracting, heating recovery is ventilation. That is also possible using the heat pumps. Basically, that's all from my side. Maybe my colleagues from Finland will add some information, or if you have any questions, just please ask, and we will try to support you and answer, clarify the details. Yeah, I just want to summarize that the main message is that we are providing all systems. So it means we are providing the conceptual drawing of the system, the selection of the device, and other hydronic components. And then we offer, of course, the main devices. It means heat pumps and all this additional already assembled parts of the installations. So if you consider such system in your stores or in your places, just contact with our colleagues and we will cooperate with such projects. We also involve some engineers from Germany for that and step by step going to the good end and effective system. So thank you very much for your attention, and if you have any questions later, you can contact me. I will leave the contact to my colleague, and also you can find me on the Polish website dimplex.pl. There are the contact data to me, the email address and the phone number, so I'm ready for helping every time. Thank you.